Good morning, guys. Welcome to day 96 till I'm a YouTube millionaire. And I just wanted to talk a little bit today about various thought experiments of different planets that could possibly exist throughout the cosmos. Now, let me use the subject of my master's thesis, Uranus. Always such a funny name, right? A name that will never be forgotten because it's a funny name. As an example. So Uranus, most people think it's just a gas giant out there, for those who even recognize that it is a planet, because honestly, most people don't even know that it's a planet, because most people don't know a lot of stuff. It is what it is. But yeah, it's a planet out there that it's outside the orbit of Saturn, right? Orbits the sun every 84 years. And most people think that do know of its existence that it's simply a gas giant. Actually, like the meme, anyways, it is a water giant or an ice giant, is what scientists, astrophysicists, astrologists call it, astronomers. And that is, it is big enough to have a very, very large atmosphere, but it's not all gas. If you pierce its huge veil, which is 5,000 kilometers thick, so it's a very, very big atmosphere, then below it, at its nominal surface, is a gigantic ocean of liquid water. Not ice. It's water. Liquid. And this is a planet that's billions of kilometers away from the sun. Its nominal surface is 117 degrees Fahrenheit. We've actually sent probes to it. We know. We have the data. And what causes that is the very thick atmosphere. It allows the planet to hold on to more of the solar energy that it gets than almost any other planet in the solar system. So the very little bit of light that it gets out there, combined with its own internal heating, which it does have some, means that it is significantly warmer at its surface than one might expect. And the black body temperature out there, that is the temperature of the void, is 65 Kelvin approximately. So very, very, very cold. Very cold. Yet it's warm enough to be a hot summer day at the nominal surface of Uranus. And the gravitational pull at said nominal surface is actually significantly less than Earth. It's like 9/10 of Earth's gravity. It is, in those ways, actually fairly balmy and reasonably survivable. However, the pressure is 100 bar. It is very, very high pressure. There's also no or very little oxygen. There is some. The amount of oxygen on the surface, though, the nominal surface, is, I would submit to you, enough to breathe because of the density of the atmosphere, the pressure. So it's assumed that it's like 0.1% of the atmospheric density at that spot. Now, if it's 0.1%, if you look at the atmosphere as being 100 times as dense as that of Earth, then 0.1% multiplied by 100, well, you 10% the amount of oxygen at its surface compared to Earth, which would probably be hypoxic, but it's not too dissimilar from the peak of Mount Everest, which is about 35% the amount of oxygen that's at the surface of Earth. So it would be difficult, but I suppose it would still Now, these are rough estimates. I mean, it could very well be more than that. It could be significantly more than that. But the pressure would make it very difficult. However, just like we've done with our diving experiments, you can actually acclimate to high pressures like that. You just have to go down slowly. In the same way that when you're down very deep in the ocean, you have to go up in pressure. Coming back up, you have to reacclimate. You have to reacclimate to the pressure at the surface by staying in a isolation chamber for a while. It's the same thing that you could do with Uranus. Now, I use that as a frame of reference, Uranus itself, and the topic of my master's thesis, to discuss other potential possibilities throughout the universe. I am writing about a hypothetical planet in my novel series right now. I call it Zeta Reticuli Beta. So it's the second planet that orbits the Zeta Reticulan dual star system. And it is a water giant, just like Uranus, but not quite as large, not quite as thick of an atmosphere. 20 bar pressure, so 20 times the surface pressure of Earth. And its nominal surface is like 110 degrees Fahrenheit or so. And it's an ocean planet. By the way, Uranus has a rocky core. So if you were to strip it of all of the water on it and all of the atmosphere, it would be a rocky core that is just about the size of Earth. Crazy to think about, eh? The reason it got to where it is because it was basically the big man on campus out there in that part of the solar system and swept up all the other little objects. It became what it is. But this hypothetical planet orbits around a red giant in the dual star system of Zeta Reticuli, and its nominal surface is 20 bar pressure, all liquid, but survivable. Much more so than Uranus. Imagine what such a planet would be like. Now, obviously, if you're orbiting a red dwarf, then you have to orbit a lot closer to get the same amount of heat energy. So, if it were in the nominal habitable zone, and this is kind of the point I'm trying to make here, then it would be an orbit of like 40 days at the very outer edge of said habitable zone. But the thing is, the habitable zone of a planet is not just contingent upon the solar energy that a star outputs. It's also contingent upon the type of atmosphere that said planet has, and the size of said planet. So Zeta Reticuli Beta could be orbiting at a 100-day orbit around a red dwarf, have a black body temperature of 100 Kelvin out there, even less, and still be getting sufficient solar energy from the star to be warm at its nominal surface. So the habitable zone, we don't quite understand. There could be potentially an infinite habitable zone, especially if you consider artificial means of manufacturing atmospheres and putting certain very highly greenhouse effective chemicals into said atmosphere, such as sulfur hexafluoride, which is 20,000 times as effective at retaining solar heat. So, realize how little we actually know about the universe in which we live, and how we have to start somewhere. The information we have put out about Goldilocks zones, habitable zones, is based upon what we have gleaned from our experimentation and scientific studies thus far. Everything still needs advancement. So, could you be the person that brings us to the next level of understanding in that? One of you might be. All right, guys. That's it. That's all I got for today. Love y'all. Peace.